You know the feeling before you ever see it. A presence that doesn't announce itself, a movement that leaves no footprint, a hunter that can be inches away without stirring air. Every other predator gives you something to hear, or smell, or sense. Snakes don't. They trade in silence, in patience, in split-second violence that ends before your brain has fully decided to be afraid. They do not roar to warn you. They do not chase to intimidate you. They wait, and they win. The unease they trigger isn't simple fear. It's recognition. Somewhere deep in our animal history, we learned that this shape, this glide, this sudden strike, meant the end. Cultures far apart in space and time carved that recognition into story and symbol. Serpents as gods, serpents as devils, serpents as guardians of knowledge, medicine, rebirth, and death. How can the same creature be a healer's staff and a sign of mortal danger? Because snakes are both. A paradox that survives by balancing opposites. Stillness and speed, simplicity and sophistication, vulnerability and lethality. There is a peculiar logic to their design. No limbs, yet mobility across rock, sand, and water. No external ears, yet sensitivity to vibration that can translate footsteps into maps. A mouth that seems too small, yet a skull that unlocks into astonishing flexibility, bones sliding past each other with ligaments like elastic bridges. A throat that can keep breathing while the rest of the head is busy swallowing something as big as the head itself. A left lung reduced to make room, a right lung elongated to act like a bellows. A forked tongue, not for taste, but for gathering chemical whispers and mailing them to a hidden laboratory in the roof of the mouth. A face that sees heat, literally. If there is such a thing as design by necessity, snakes are its thesis. Nothing wasted, everything aimed at survival under pressure. Here is the unsettling part. Some mysteries that people once wrote into myth turned out to be true in stranger ways than the stories. Legless, yes, but under the skin, in certain lineages, the ghosts of legs still linger. There are tiny bones in some bodies that do not touch the ground. Spurs beside the tail of a boa or a python, not for walking, but for grasping during courtship, leftovers from a blueprint discarded millions of years ago. There are fossils with legs you would never expect to find on a snake. There are marine snakes that never see land, breathing trapped air, nursing venom designed for fish. There are snakes that spit venom with such accuracy that eyes become their chosen target. There are species that bear live young in cold climates, and species that brood their eggs, warming them by shivering their own muscles. There are snakes that climb glass-smooth bark, and others that bury themselves so completely that only the eyes remain. The catalogue reads like a dare to the imagination, and yet each impossibility is simply an answer to a problem nature posed. Snakes force a question that feels personal. What does it actually mean to be dangerous? Is it size? Not necessarily. Some of the most toxic venoms belong to slender, modest animals. Is it strength? Constrictors win with pressure that stops blood faster than suffocation can starve air. The heart has nothing to push against and quits. Is it speed? Many strikes finish in less than 1/7 of a second. The victim doesn't run, it realizes. The danger, then, is mastery. A suite of solutions so well-tuned that even a small body can topple larger lives. And yet the same mastery delivers services we rarely respect. Rodents controlled in fields and granaries, disease risk lowered not with antibiotics, but with appetite. The more you look, the more the caricature of mindless killer crumbles. These are not monsters. They are problem solvers, refined by catastrophe after catastrophe. Catastrophe is not a metaphor in their story. Whole ages collapsed and snakes persisted. When the skies dimmed and food vanished and cold came where heat once reigned, they slowed themselves to a whisper and waited for the world to breathe again. Where others needed much, snakes may do with little. A long fast that would starve a mammal is part of a snake's year. A burrow that shelters a rodent becomes a bunker against winter. They are not immortal. They are not invulnerable. They are simply better at doing nothing when nothing can be done, and then perfect at doing everything in the instant when opportunity returns. If survival has an art form, this is it. Some facts press harder on the imagination than fiction can. There was a snake longer than a bus, thicker than a person's chest, gliding through hot, swampy rivers. There are snakes today that can sense the body heat of prey in total darkness with enough precision to place fangs on a heartbeat. There are venoms assembled from repurposed salivary enzymes and blood-clotting tools, turned by evolution into chemical keys that lock the body against itself. Nerves silenced, muscles frozen, vessels leaking, hearts confused. There are skulls where the most important bones are not rigid like shields, but hinged like doors, flexible like drawbridges, letting a snake do what nothing with a fixed jaw can do. Take the world in large pieces. A strange truth sits under all of this. Snakes were not born snakes. They were made, increment by increment, from small lizards that fit between roots and stones better when they stretched longer and pushed less with limbs. The hook of this whole story is that what frightens us most about snakes, their otherness, came from ordinary steps, not magic leaps. Limbs didn't vanish because the animal stopped using them, as if disuse were a moral failing. Limbs shrank because bodies that moved like ropes through tight places fed more often, escaped more easily, and bred more successfully. Jaws loosened because a skull that could ratchet over a meal meant fewer risky fights with prey. Heat sensing evolved because a night hunter in open ground needed a way to see without light. Venom sharpened because speed demanded a weapon that killed the chase. None of it was planned. All of it works. That is the unsettling elegance of evolution. If your mind keeps asking what else is hidden, good. That is the right question. Hidden is where this lineage lived for a long time. Under leaf litter, inside sand, inside bone. Fossils of early snakes with legs exist, but they are rare and precious, a handful of windows into a long hallway. Genetic records preserve more windows. The same pathways that build limbs in an embryo flicker on and then go dark. The same protein families that once clot blood are now deployed in venom to overwhelm it. In cobras that spit, the plumbing and the behavior agree. Enlarged fangs with forward-facing openings, neck muscles that compress the venom glands like syringes, aim that follows head movements like a thrown lance. In pit vipers, the trigeminal nerve carries the heat picture to the brain, merging it with visual information into a map more complete than either alone. The result is a predator that can hunt when eyesight would lie. It feels unfair, almost. But unfair is not a category nature recognizes. And yet for all this menace, there is discipline. Snakes avoid waste. They spend most of their lives not hunting, not fighting, not moving. They keep their bodies at a cost they can afford. A meal is not a snack. It is an investment to be stretched across weeks. Skin is not shed randomly. It is renewed when growth or parasites or wound healing demand replacement. Even danger displays are thriftier than they look. A cobra's hood, a rattlesnake's buzz, a false strike that stops inches short. Warnings that conserve energy by preventing fights they would rather not have. The paradox returns. Terror as restraint. The smartest thing a snake can do is nothing until doing something will certainly pay. That pause, that coiled margin between stillness and action, is the edge this story walks. It is the feeling that carries you from unease to curiosity, and then to understanding. And now that the ground has shifted under your feet, now that the category of snake has complicated itself with ghosts of legs, laboratories of venom, and calculators of heat, here is the path through the history that made them. Snakes descend from lizard-like ancestors that thrived during the late Jurassic and early Cretaceous, about 160 to 100 million years ago. These were not giants. They were small hunters navigating cramped environments where a long, low-profile beat splayed limbs. In the fossil record, one of the most revealing forms is Najash, discovered with a defined pelvic girdle, sacrum, and a pair of hind limbs, all attached to a body already built for slithering. Najash was terrestrial, moving primarily by undulation across firm ground, with legs likely recruited for anchoring during mating or for helping in tight turns and burrows. It is a reminder that locomotion changes before anatomy finishes catching up. In another branch, Pachyrhachis appears in marine limestone from the late Cretaceous with stout ribs and dense bones, features that act as ballast in shallow water, and tiny, non-functional hind limbs retained as vestiges. Its habitat and skeleton argue for a phase where some snake ancestors exploited aquatic niches while the blueprint was still in transition. Skull architecture transformed in parallel. The quadrate bone, hinged in lizards, became more mobile, and other bones of the upper jaw decoupled to allow wide gapes. Teeth arranged in recurved rows pointed backward, holding prey like fish hooks. The glottis, the opening to the windpipe, shifted forward so that a snake could continue breathing while its mouth was wrapped around a meal that hid the mouth itself. Internal organs shuffled to fit a body shaped like a cable. The heart sits far forward, the left lung is reduced or absent, the right lung lengthened. Hundreds of vertebrae, each with ribs, turned the body into a locomotive engine with fine-grained control over force and direction. Out of this engineering came a repertoire of movements: lateral undulation for swimming and everyday travel, concertina for tight tunnels, rectilinear for slow, straight progress with belly scales gripping like a tank tread, and side-winding for low-friction sand where other gates fail. Limbs became unnecessary, not by decree, but by redundancy. Then the world broke. At the end of the Cretaceous, 66 million years ago, an asteroid impact ripped through the biosphere. The food webs that supported giant dinosaurs collapsed. Snakes sat at an advantage almost by accident. Small bodies that could hide, low metabolic needs that tolerated famine, a lifestyle already adapted to waiting. Many lineages vanished, but enough survived to seed the radiation of the Paleocene and Eocene, when heat and humidity returned and tropical forests spread. In those conditions, an ectotherm can grow very large without losing function, and one lineage did. Titanoboa. Estimates from vertebrae place its length around 13 meters. It likely hunted like an anaconda, semi-aquatic, ambushing in water where buoyancy supports mass and leverage increases. Its existence is a climate echo as much as a biological one. Huge reptiles thrive when ambient temperatures are high and resources abundant. Titanoboa is the fossil reply to the question, how far can this design go? As climates cooled through the later Eocene and into the Miocene and Pliocene, forests contracted and mosaic habitats of woodland, savanna, and grassland expanded. Ambush in dense cover gave way, in many lineages, to hit and run in the open. Venom became the decisive innovation. Salivary proteins with modest roles, digestive enzymes, regulators of blood chemistry, were duplicated and diversified. Selection sharpened them into tools that disrupt nerves, coagulate or anticoagulate blood, punch holes in membranes, and cause catastrophic pain. Delivery systems specialized along different paths. Elapids, cobras, mambas, coral snakes carry short, fixed front fangs, proteroglyphs, optimized for quick neurotoxic strikes. Vipers built long, hinged, hollow fangs, solnoglyphs that fold against the roof of the mouth and swing forward at the moment of attack, usually deploying hemotoxic cocktails that destroy tissue and circulation. Rear-fanged colubrids evolved grooves and partial solutions that, in some species, still kill prey efficiently. In spitting cobras, the openings of the fangs shifted forward, and behavior evolved to weaponize distance. Jets of venom target eyes with astonishing accuracy, deterring large mammals long before a bite would be possible. Sensory worlds broadened in tandem. The forked tongue is not a decoration. It samples 2 points in space at once, carrying chemical particles to the vomeronasal, Jacobson's organ, where the brain triangulates direction like a living compass. Many boas, pythons, and pit vipers added infrared detectors, pits along the lips or a pair between eye and nostril, that image heat. The brain fuses that information with vision, constructing a target from warmth and shape. Hearing in the air is poor, but sensitivity to ground vibrations is profound. A jaw touching the earth becomes a seismometer that hears footfall through stone. The eyes are protected by a clear scale, the spectacle, fused into a transparent lid that is replaced with every shed. Nothing about these faces is ornamental. Everything is function. Reproduction diversified with habitat. Oviparity, egg-laying, persists in many groups, often with carefully chosen nest sites and, in species like pythons, maternal brooding that warms the clutch through muscular shivering, a rare case of parental care among reptiles. Viviparity, live-bearing, appears in cooler climates and aquatic snakes, where retaining embryos improve survival. Parthenogenesis, development of embryos without fertilization, occurs occasionally. A genetic hail, Mary that keeps a lineage alive when mates are absent. Courtship can be gentle or violent. Males of boas and pythons rake those vestigial spurs along a female's flanks. Male rattlesnakes wrestle in combat dances that end when one pins the other. Even here, the theme holds. Nothing wasted. Signals are cheap, outcomes decisive. Locomotion reflects the ground under the body. Lateral undulation propels through water and across most terrain by pushing on small irregularities with waves that travel head to tail. Concertina movement anchors part of the body, while another extends, fastening forward like a climber with 2 hands and 2 feet, except there are none. Rectilinear progression inches forward with belly scales, powered by muscles that attach to ribs, nearly silent and perfect for stalking. Side-winding lifts segments from the hottest sand, placing the body down in discrete, cool footprints, minimizing contact where heat would otherwise disable muscle. These are not tricks. They are solutions to friction, gravity, and heat, rehearsed for millions of years until they look like magic. Predation strategies mirror this physics. Constrictors kill not by suffocation over minutes, but by blood pressure collapse over seconds. Sensors in the body feel the heartbeat falter and tighten precisely until the heart can no longer perfuse the brain. Venomous snakes sometimes hold, often release, tracking a struck animal by scent to avoid retaliation. Arboreal species hang in loops from branches and launch like arrows across gaps. Burrowers hunt by feel in the dark, jaws built narrow and strong to pull worms and small vertebrates from tunnels. Sea snakes carry paddle-like tails and sublingual salt glands. Many breathe less often than you'd expect because their skin exchanges small amounts of gas with water. The same simple body plan filters into 100 professions. By the time the ice ages of the Pleistocene rolled across the northern hemisphere, snakes had already built a toolkit to match austerity. In cold regions, many retreat underground and enter brumation, a metabolic slowdown that conserves energy through months where prey is unavailable. Communal dens collect hundreds of individuals, heat shared by geometry more than cooperation. When glaciers advanced, ranges shrank toward the equator. When they retreated, snakes recolonized ground with the patience of plants and the appetite of predators. Large mammals disappeared at the end of the Pleistocene, dire wolves, saber-toothed cats, mammoths, but snakes, mostly small and thrifty, endured the swings. They are not the stars of Ice Age murals. They are the footnotes that never end. The modern world hosts almost 4,000 species, spread across nearly every landscape except Antarctica. In deserts, sidewinders etch their signatures into dunes. In forests, green tree pythons hang like leaves. In rice paddies and cities, rat snakes do quiet public health by emptying granaries of pests. In the open ocean, olive sea snakes glide over reefs. In rivers, anacondas turn water into leverage. Some snakes specialize to razor-fine niches, mimicking the colors of the dangerous to borrow protection, imitating the smells of prey to draw them closer, even copying the rhythm of a harmless rustle to calm suspicion. Others remain generalists, changeable as weather. The price of failure is paid in extinction notices you rarely see. The reward for flexibility is written in maps that color continents. Humans complicate this picture. Habitat loss, road mortality, and persecution shrink numbers in many regions. Trade, legal and illegal, removes bodies from ecosystems that counted on them. Invasive snakes transplanted by us become problems where prey lack defenses, as with Burmese pythons in the Everglades. And yet, coexistence is not a fantasy. Education turns fear into caution. Relocation replaces killing in cities that have learned a different reflex. Farming that tolerates wild edges gains free rodent control. Conservation that protects wetlands and forest corridors helps snakes by accident while aiming at birds and mammals on posters. The web tightens either way. Break it here, it slackens there. Under all the detail, a few principles carry the weight. Simplicity is not the enemy of sophistication. A long tube with a mouth can be an apex design if the tube is built from 1,000 articulations and the mouth from 1,000 freedoms. Losing parts can be gain when the world you move through punishes bulk and protrusions. Patience beats haste where mistakes are lethal. Silence is a strategy. Waiting is a weapon. And evolution, blind, iterative, indifferent, can sculpt fear itself into a tool for survival. If you feel that tool scraping your nerves when you think about snakes, that only means it worked. So what remains when the fear calms and the fascination stays? A lineage that began as small lizards underfoot and became a global experiment in efficiency. A record of disasters survived not with heroics, but with austerity. A living library of solutions to heat, cold, famine, friction, darkness, and danger. And a reminder that what we call monstrous is often just perfected for a job we would rather not imagine doing. The next time a shadow in grass resolves into scales, you are not looking at a mistake of nature or a villain written into the world to scare children. You are looking at the outcome of 160 million years of editing. You are looking at jaws that began as hinges, bones that became doors, saliva that turned to lightning, a tongue that reads wind like a sentence, eyes that see what light does not show, a spine that is both bridge and engine. You are looking at survival with ornament stripped away. And that is the last turn of the hook, the realization that the dread you felt at the start has been replaced by respect, even a kind of awe. Snakes did not outlast dinosaurs by winning every fight. They outlasted them by learning when not to fight, by needing less, by exploiting the quiet corners of changing worlds. They are still doing it, in our fields, our forests, our rivers, our walls, whether we notice or not. As long as there are hidden places, there will be serpents to inhabit them. As long as the planet keeps bending without breaking, there will be bodies that can bend with it. And if we can learn to see them as they are, neither demons nor saints, but masters of restraint and precision, then this story, which began with unease, ends where understanding always ends, with humility.